All right, good afternoon. My name is Sungchul Jung. One nice thing is I recently, actually 3 months ago, I completed my PhD at the University of Central Florida under supervision by Professor Hughes. And I'm now at the heat lab. Oh, sorry. It works? Okay. It's okay? Or this side? Yeah. Give me 1 second, please. Do I start? Just
continue. Yeah. Please
okay.
just continue.
All right. So I'm going to talk about our research here. So I'm going to talk about these issues in this presentation. Before I talk about my research, I would like to remind you some VR components they used in my paper as dependent variables. The first one is body ownership. The body ownership is a well-known concept in psychology where it is viewed as a fundamental aspect of self-consciousness of one's own body. The rubber hand experiment is a famous example of body ownership that depicted in the first image. The experimenter placed rubber arm near the participant arm and give a tactile feedback using brush or certain other tools. Then, surprisingly, the participant felt the rubber arm as if their own arm. So this kind of a concept of body ownership naturally extended to virtual reality because understanding a given virtual body is important for a sense of illusion in VR, while the virtual space provides a flexible environment for such experiment of body ownership. Presence is a bit different concept than body ownership. Simply, we could say presence is a sense of being in VR space. The leftmost frame depicts a well-known study of presence. So depending on the feature of the presence, we could categorize the presence as co-presence, spatial presence, and social presence. So in this paper, we only focus on the spatial presence. I'm going to talk about a bit different dependent variables, that is accuracy of size estimation. In our daily life, size estimation is frequently aroused at the perceptual level. However, the sensation could be different between being in VR and being in real world because there are many variant factors in VR virtual environment, such as narrow field of view, different avatar size, and then different viewpoint as well. Then, what could be an invariant even inside of VR? Let's assume we don't have such a measuring tool or any size comparable virtual object inside the virtual environment. Then one possible answer could be use our personal hand. Because we know our hand shape and size information at the perceptual level as well. That is why a human uses their hand for size estimation explicitly and implicitly. So we code it as a body-based scaling scheme. Then our primary research question was, does one's personalized hand provide better size estimation of the virtual object in virtual environment compared to general avatar hand? To investigate the answer, we asked each participant to manipulate the virtual object size. In this case, we asked the participant to manipulate the virtual box in here. and why they had a personalized hand or generic avatar hand. Here is our experiment design. We have 3 independent variables. One is hand representation, other one is matching task type and the box size. In this experiment, we provide 2 types of hand. The first one is a personalized augmented virtuality hand. So the participant can see their own hand. Where is it? Own hand here. Otherwise, sometimes the participant also had a general avatar hand, which has a gender neutral and also has a average hand size. We decide the hand size based on previous research by Gerd. In the matching task type, we provide 2 types of matching task. The first one is a relative size matching task, and the second one is an absolute size matching task. The relative size matching task means we provide a observation time to observe the physical boxes, as you see the images. So after the participant observe the physical box in real world, then when they get into the virtual environment, we ask the participant to manipulate the virtual object size compared to the physical box size. In absolute size matching task, we only verbally ask the participant to do the virtual box size according to certain fixed number. In our experiment, we used the 5 centimeter and the 38 centimeter. Depending on the participant preference regarding the unit, we used the centimeter or inches, but the size was the same. So here are our hypotheses for this experiment. In terms of a virtual body ownership illusion, when participants have a personalized AV hand, then the AV hand will provide a higher sense of virtual body ownership illusion rather than general avatar hand. Similarly, in terms of spatial presence, the personalized AV hand will provide higher sense of spatial presence rather than general avatar hand. In terms of size estimation, the personalized hand will provide a better relative object size estimation accuracy rather than general avatar hand. But regarding the hand representation, when participants were asked to draw the virtual object size according to an absolute size matching task, especially the large number, which is 38 centimeter, then the accuracy will be low. This picture shows our experimental setup. To render a personalized AV hand, we used the chroma key technique using stereo camera attached to an HMD. And the camera has 45 FPS and 1280 by 960 degrees. To give a simple size manipulation, we used the trigger button to increase the box size, or using the touchpad to decrease the box size from the Vibe controller. This is our experimental protocol. We gave an informed consent first, and we asked the participant to fill out the demographics. And this is an interesting step, because even though we provide the augmented hand, sometimes maybe we concerned that the participant could not identify the hand as their own hand. So we asked the participant to draw something feature over their hand using the washable paint. After that, we gave an instruction, and we gave an observation time to physical boxes one by one. After that, the participant will get into the VR space and then conducted with the first task. Between the tasks, we gave a short break, and we resumed the second task. After that, the participant were asked to fill out the questionnaire. And then we repeat the same procedure here. After participant complete all the experiment, because we ran this experiment with a within subject test, then the participant will ask to fill out the post questionnaire. I would like to share some video here. Yep. So this is the time for the box observation. We ask the participant to observe their hand with the same position. After that, when participants get into the chroma key room, we ask the participant to have a same position as well. So as you see there, the hand has some features, and then this is the relative size matching task, the second one, when participant having the personalized hand. I'm sorry about that. Oh yeah, you can see that, yeah. Between the task type, we gave a short break time, and we resume the task with a different task type. So in this case, that is an absolute sizing matching task with a 5 centimeter drawing. After that, the participant conducted the second task with a 30 centimeter box size drawing. Then we asked the participant to fill out the questionnaire. After that, we resume the task with a different hand condition. So the participant had a general avatar hand, and we repeated this experiment with the same order. Can you see the cursor? I don't see it. So I'm going a bit faster. And then this is the last condition. When participants have general avatar hand with absolute sizing matching task with a 38 centimeter. Okay. So we determined the required number of participants before we ran this study using power analysis with a power of 0.8. And it indicates that we need 24 participants. We had to exclude one participant data because the participant failed cyber sickness. We recruited the participants who have normal to corrected to normal vision only. For a subjective response, we used the Bailey's questionnaire for presence and self-presence, while we used the Slater's and the Argerlagos questionnaire for virtual body ownership illusion. Because we used a lot of questionnaire source from questionnaire from different sources, so we calculated construction validity using Cronbach alpha test, and it shows over 0.7 for all of the questionnaire. So we decided to adopt the result from the questionnaire. This is our result. There is a put result for the size estimation. We calculated a vector distance, so the values which are close to 0 represent more accurate size estimation. Also, we drew the lines onto the histogram for the vector distance. So, as you see the graph, the red and the yellow solid line that represent when participants have the personalized hand when they having the relative size matching task, the first one and second one as well. And then that shows the highest accuracy as you see here. However, regarding this, the hand representation type, when participants were asked to draw the virtual box with a 38 centimeter, then their accuracy was low. We also ran statistical analysis here as well. We ran repeated measured ANOVA with a Shapiro-Wilk test and a macro-disparity test as well at the 5% significant level. But we did not find any significant difference at the first time. So we conjectured that The big difference could be from the absolute sizing matching task with 5 centimeter and 38 centimeter, there was a noise in the data set. So to verify the conjecture, we ran a post-hoc analysis, and we found that personalized hand representation shows a significant difference. Otherwise, the absolute sizing matching task did not show a significant difference. Also, we conducted a parity test between the box size, in which we found a significant difference between the two boxes in the absolute matching task as well. This is the result from the subjective measurement. We represented self-presence and the virtual body ownership illusion together because both questionnaire has similar factors. We used the p-value at the 5% significant level as well. Because the data did not show normal distribution, we used the non-parametric data analysis. And it all shows that the personalized hand had a significant difference versus the general avatar hand, as we see here. This is the result from the post questionnaire that is very interesting. This questionnaire was a first choice among 3 items. The blue color represents when you have your personalized hand, and the red color represents when you have a general avatar hand, and the orange color represents no difference. So when you see the right upper question, which type of virtual reality system do you prefer? So in terms of a preference of the system, about 90% participants choose the personalized hand. Which type of virtual reality system made you feel as if you were in the virtual office? This is in terms of presence. About 70% participants choose the personalized hand gave more sense of presence. Which type of virtual reality system made you feel as if the virtual arm was your own? In terms of virtual body ownership illusion question, about 87% participants choose the personalized hand allows the more sense of body ownership. Interesting part is this first question. Which type of virtual reality system made you feel more confident when estimating the size of an object? This question asks the participant their confidence regarding the size estimation accuracy or not. Only the confidence. Then about 80% of participants choose the personalized hand. When they're having the personalized hand, they felt more confident to estimate the virtual object size. In this experiment, we found the support for all 4 of our research hypotheses, as we see here. But we had a technical limitation. The first one was the stereo camera color accuracy was dropped and the noise increases after about 1 minute. And 2 participants reported that they saw a floating hand effect when they're having the personalized AV hand. The other one is 3 participants also reported that they felt difficulty controlling the virtual box size using the Vibe controller. To wrap up, this is our conclusion. We investigate the effect of a personalized hand on spatial presence, virtual body ownership, and object size estimation in virtual environment. From this experiment, we found a significantly higher accuracy and object size estimation for the personalized hand in a perceptual matching task. Also, we found a significantly higher spatial presence and virtual body ownership. Also, we found this, in general, a preference of the personalized hand compared to general avatar hand. So, based on the findings from this experiment, we could or we would recommend that VR developers or VR researchers adopt the personal hand in areas that requires a size-sensitive task, such as a surgery task or something usability task that include activities influenced by product size. So especially when we say in the usability test, handheld size could be useful with a personalized hand. This is our future work plan. We will develop an extensible experiment, including personalized body in dynamic scenario and with more complicated object. Especially to rendering the personalized hand, we will use more features from the person, which is biological features. There is a skin color, wrinkles, and one. Also, we have a plan to adopt artificial features such as watches, ring, and bracelets. Thank you for your listening. I would have your any question or feedback. Thank you.
So questions?
How did you determine the size for the virtual hand, and did you notice any correlation between those who had one that was sort of matched versus one that didn't?
Yeah. So actually, the best bet could be having the measuring the participant hand first and applying the virtual hand. That could be the best one. But actually, in this case, we use the previous data, which, give me 1 second, please. Here. So previous hand, the researcher, Gordon and other, having the data regarding Americans' average hand size in terms of width and height. So we just applied this data for our data set.
But did you notice, did you actually take measurements of their real hand and look and see if that sort of disconnect, if they had a much bigger hand than the generic hand, if that had any impact on their relative performance?
In this case, actually, we, as I mentioned, we measured the participant hand before they get into the VR session, but we only used the data to verify the data set was a reasonable thing to just adopt in this case. So actually, we didn't measure such a case, but it could be our potential research, I think.
Thanks.
Yeah.
As a follow-up, just that means that we don't know now whether it's trust which helps them to estimate the size better because they see their own hand, or whether it's the reference size of the hand because you use the same generic size of the hands for all participants, right? Okay.
Yeah.
Hi, thank you for the talk. So you talked about the future direction of research about more embodiment, skin color and everything. But I think if you get too much reflection of someone's own features, sometimes it falls into the uncanny valley, right? And people sometimes don't like to see all the features in the avatar. Right. So do you have any idea how much you want to see in the reflection?
Yeah, actually, I also concerned the uncanny valley, but actually, as far as I know, the uncanny valley could be aroused when we see especially the avatar's face. The face is even though we rendered it perfectly, but the face looks weird, then the uncanny valley will be aroused. But in this case, we plan to render our personalized body first. So which means when we have a certain personalized item, in this case my watch, or if I have some scar on my hand, then it could be give a more identification to identify my hand, but not uncanny valley, I guess.
Hi, thank you for your talk. Did you also consider the height of your participants and the different point of views?
The viewpoint?
Yes.
Yeah, actually, that is a really good point. that is the reason why actually this experiment was conducted while the participant sitting position, because we wanted to avoid a certain confounding because we don't know yet. But in the next experiment, as I mentioned here, see that? Yeah. We want to extend this experiment because this experiment was relatively statistical experiment. So we want to move this experiment to dynamic scenario, which means the participant could manipulate the virtual object size while they standing position and moving their hand or their body as well. So that is a really good point. Thanks so much.
So maybe I have one last question. We all know that in close proximity, stereoscopy is a very important size cue and depth cue and so on. So you certainly adjust therefore to the distance of the eyes of the users, which you can do for the virtual reality rendering. But can you adjust the size, the distance of the two cameras for your video see-through system?
Yeah, actually in this case we just adopt the stereo camera without adjusting the IPD in here. So that could be one of the limitation of this experiment. Yeah.
The same IPD
Yeah,
for all
yeah.
participants and the same for the virtual area.
Yeah.
Okay.
But before we conduct the experiment, we always confirm that if the participant having the comfortable to see around the virtual environment, and then we don't have any report regarding the uncomfortable. So, yeah.
Thank you again. To thank the speaker again. And